Okay, so this will be our next example. This time we have a mixture of dependent and independent sources. Independent current source and independent voltage source. Dependent voltage source, which is current control, and dependent current source, which is also current control. Okay, remember this, whenever you are using superposition theorem, no, only include independent sources in superimposing the effect of one with respect to the others. Huwag mong isali yung mga dependent sources, either current or voltage. Ang isali mo lang is independent current and voltage sources. Dalawang beses lang ito. We are required here to obtain your V. So the actual current direction here is left to right. Tama? Supposing that this is given by I. Okay? Since by Ohm's law, your V is 40 times I. But your I is given by two components. One component is coming from your 2 amperes and the other one is coming from your 64 volts. Supposing that, let us try to mark this one as terminal 1 and the other one is terminal 2 for easy recognition. So this is I12 and that is your I12 prime plus I12 double prime. Okay, let's now have your I12 prime. For I12 prime, I12 prime is considering the effect of 2 amperes let us replace your 64 volts with short circuit. Okay, 2 amperes, 80. Plus and minus V, terminal 1 and terminal 2. Okay, let us assume that the current here is from left to right. So this is your I12 prime. That is your 2I2. We have here your I2. And this is our I1. 2.5 I1. Okay, we can easily obtain your I12 prime, no, by merely using your current divider using your loop analysis. The circulating current here is given, that is 2 amperes. We have another circulating current here, another circulating current, and the last circulating current being your C. Okay, so we just need 3 equations, no? One is coming from this, from loop C, the other one is from the dependent current source, and of course the last equation is by way of KVL dito. Yan. This is from loop X. Okay? So unahin natin yung loop X. KVL at loop X, negative 80A, correct? plus 80 times 2, correct, minus, okay, this is 8 ohms, 40 minus 8A plus 8C minus 40B plus 40 times C is 0. Okay, if we will try to combine similar terms, this one, the other one is negative 88A minus 40B. Ito, 8C plus 40C is plus 48 times C is 0. Okay, equation 1. Next is a KVL at loop C, or a loop current equation at loop C, or from this dependent current source, loop current equation at loop C to obtain negative C times 40 plus 8 plus 8A plus 40B plus 2I2 is 0. And you need to express your I2 in terms of the other circulating currents. What is I2 equal to? I2 is the difference between two circulating currents, namely A and C. So this is negative 48C plus 8A plus 40B plus 2 times A minus C is 0. Okay, if we simplify, negative 48C plus 8A plus 40B plus 2A minus 2C is 0. And combining similar terms, what you have is 10A plus 40B minus 50C. Do we have any other constant? Wala na. And that is 0. So this is equation 2. Okay? Next, from this dependent current source, that is, and dependent current source which is current control. So at the dependent current source which is current control, 2.5 I1 is the difference between your two circulating currents, that is B and A. 2.5 I1 is therefore B minus A. What can you say about your I1? Your I1 is the same as your B, because there is no other circulating current affecting the value of I1. Ito. Simplifying, 2.5 times B is equivalent to B minus A. If we try to transpose it at the other side, that is A plus 0.5 or 1.5, correct? 1.5 of B is 0. This is equation number 3. Okay? And you can use your calculator to solve for the value of A, B, and C. Solving, what is A, what is B, and what is C? First value is 2.069. And the value of B is negative 1.379. And the value of C is negative 0.690 amperes. And we are now ready to obtain your I12. So your I12 prime is the difference between B and C. B minus C. Okay? So your B is negative 1.379 minus negative 0.690. So your I12 prime is negative 0.689. 0.689 amperes. Okay? Sulat natin dito. Our I12 prime is negative 0.689 amperes. Okay? So we are now ready to proceed with the next part of our solution. Okay?